Okay, so we've been talking about volumes and surface areas. We've talked a little bit about converting. I want to take a look at something today that I want you guys to do some work on. Thanks, sir. Okay, so what I want you to do on this is I want you guys to find volume and surface area. There's a catch though. This table right here, I want you guys to do it in inches. The rest of you, I want you to find volume and surface area in feet. So if we're doing this in feet, we're going to find the area of the base, which is just going to be the 8 times 4 or 32 square feet, correct? So the volume is going to be the 32 times 3 or 96 cubic feet. Is that what you guys came up with? Okay, for inches, what did you guys come up with?
I came up with 165,888.
Okay, well, let's check and see if Drew is on track or not. Area of the base is going to be 96 by 48.
Wait, what?
Area of the base is 96 by 48, right? So 4608 square inches. So the volume is 4608 times 36, otherwise known as, Drew isn't crazy, 165,888. Surface area. For feet, surface area, the area of the base, of course, we've already got is 32. For lateral area, we've got the perimeter of the base, which is 24 feet, times the height of 3, which is going to be 72 square feet, plus 32 and 32, which is 136 square feet is our total surface area. For inches, we have the area of the base already of 4608. So we're going to do the perimeter of the base for the lateral area. Perimeter of the base is 96 by 48, which is 144, 288 times 36. 10,368. Then we're going to add the 4608 to that twice. $19,584, you said? That sounds right to me. Inches squared. Now I did this problem for 2 reasons. 1, a little bit of review, but 2, to point out that what's the conversion? If I want to convert cubic feet into cubic inches, what am I doing? Multiply by 12 3 times. There you go. 96 cubic feet. Last warning, guys. It's actually 12 to the 3rd power, or 1728, which gives us the 165,888. So that conversion holds true. If we were converting the surface area, however, of 136 square feet, what would we multiply by? 144, which does give us the 19,584 square inches. So in our standard system, if we're converting volumes, we have to make sure we're using that cubed conversion factor. For converting areas, we have to make sure we use the squared conversion factor. So what if we are doing piece of concrete that is 6 inches thick, 32 feet long and 18 feet wide. Find the volume in cubic yards for me. Okay, so first thing we'll notice is that these two dimensions are in feet, and this is in inches. To turn 6 inches into feet, I'm just going to make it 6/12 of a foot, or 1/2 of a foot. So now we've got 32 times 18 for the area of the base, which is what, 576? Times 1/2 to get the volume, which is 288 cubic feet. How do we turn that into yards? Not multiplied, but divided by 3 times. So 3 to the third, or 27, which is going to give us, what, 10.67? Is that what you got? 10.66666. 3 times, because it's cubed. 1 cubic yard is 1 yard by 1 yard by 1 yard, so 3 feet by 3 feet by 3 feet. Okay. So in the metric system, let's do this. Come on. Come on. So let's say that this is 40 millimeters by 70 millimeters. Find the area. (2,800 millimeters squared, right? Yeah. What if I was doing that in centimeters squared? This would be 7 centimeters by 4 centimeters, or 28. Now, how many millimeters are in a centimeter? 10. We looked at the chart. We had meters, decimeters, centimeters, millimeters. To get from millimeters to centimeters is 1 spot to the left. You move the decimal point 1 spot to the left. That's why 40 became 4 and 70 became 7. But when it's square millimeters and square centimeters, that doesn't hold up, does it? No, each spot on the chart is 10 by 10, or 100. So when you multiply or divide by 100, the decimal point moves 2 spots. So let's say that this is 50 millimeters. What's the volume in millimeters? In millimeters cubed, that's just going to be the 2,800 square millimeters times 50, otherwise known as 140,000 millimeters cubed. What if it's centimeters cubed? Well, this is going to be 5.0 centimeters, right, or just 5, which is going to make it 140 centimeters cubed. So when it's area, because it's cubed, or when it's volume, because it's cubed, each spot on the chart is 10 by 10 by 10, or 1,000. So you're moving 3 decimal places. Sure. So for this one, find the area. So you come up with 9,600 square centimeters, right? What's that going to be in square meters? 0.96, good. On the chart, centimeters to meters is 2 spots to the left, but it's squared, so each spot is 2 decimal places, so it's 4 decimal places. 1, 2, 3, 4. So let's say that this is 30 centimeters high now. Find the volume in centimeters cubed. So you get 288,000 centimeters cubed. So what if I was taking this into meters cubed? Well, it's still, from centimeters to meters, is 2 spots to the left, but now it's cubed, so each spot is 1,000 or 3 decimal places. So it has to go 2 times 3 or 6 spots. 1, 2, 3, 4, 5, 6. 0.288 meters cubed. You can use the numbers to verify. Well, where are some spots that these conversions are useful to us? Well, one of the things you guys are going to look at is, or you've already probably looked at, is board feet. Have you done this in the shop yet? Yeah. Did it in blueprint reading? Okay. What is a board foot? You got it. Board feet comes from the fact that lumber used to be rough cut at 1 inch thick. So a board foot was a square foot of a board. It's 1 inch thick by 12 inches by 12 inches. In other words, 1 foot by 1 foot by 1 inch is a board foot. Giving you a volume of how much? 144 cubic inches. And that's probably the simplest way to do board feet these days, is to just find a volume and convert. So let's say that I have two by 8 by 16 feet long. How many board feet are in that? Well, I could use this 144 cubic inches as a conversion, but to do that I'd have to turn my 16 feet into inches, which would be 192 inches, and then multiply it out. And that works. 2 times 8 times 192, oops, 92, 3,072 cubic inches, and then divide by the 144 to convert it down to board feet. 21 1/3 board feet. But I think there's an easier way of doing it. There is something called board foot per linear foot. For every dimension of lumber, you have a certain number of board feet in each linear foot. So we had a 2 by 8. I'm going to take that as 12 inches long. That's taking 1 linear foot of that board, which is going to give me 192 cubic inches. So 1 linear foot of that 2 by 8 contains 192 cubic inches. So if I divide that by 144, I get what? 1.33. So it's 1 1/3 board feet per every linear foot of that lumber. Now that I have that, all I'm going to do is take that 1 1/3 times my length of 16 feet. You have to talk to him. I'm sure he's just worried about getting an accurate board footage. The 192, it's a 2 by 8 is the lumber. Then the 12 inches, because we're just looking at 1 linear foot. Yep. So let's say we have 2 by 6. Now again, we're assuming we're only looking at a 12-inch piece. So the cubic inches per linear foot that's 2 by 6 by 12 is 144. So you divide that out, you've got it. You divide by 144 cubic inches in a board foot, that is 1 board foot per linear foot. So now whatever the length is of 2 by 6 that you need, that's your board foot, because it's 1 board foot per linear foot. Now does Chris make you do 2 by 6 or does he make you do 1.5 by 5.5? Haven't done that yet? Okay. Most of the time when you're buying lumber, even though it's actually only 1.5 by 5.5, you are going to buy the full nominal dimension rather than the actual dimension. So find 1 board foot per linear foot and 2 total board feet. 4 2-inch by 12-inch by 24 foot. So to find board feet per linear foot, it's 2 by 12 by 12, otherwise known as 288 cubic inches. So we divide by 144 to get 2 board feet per linear foot. So that means then that 24 feet of that is going to be 48 board feet. How many of you had 48 board feet? Good deal. Now I'm going to show you a spot where this actually comes in quite useful. Pretend that's a rectangle. There. Let's say that this is a 14-foot by 32-foot deck. And we're going to cover this deck with 5/4 deck plank. Tight. Seriously. When I use green treated, I space them as tight as I can because they're still going to shrink and you're going to get a 3/8 inch gap anyway. 5/4, especially if you're going from Menards, you're going to get a 1/4 to 3/8 shrinkage. Because you work there, Drew, and I want to see you. So anyway, to find the board footage of this, it's 14 feet by 32 feet by 1 1/4 or 5/4. So my calculator, I can just do 14 times 32 times 5 divided by 4. And I get 560 board feet required for this. Now on a 5/4 deck plank, 5/4 by 5.5 by 12 inches. Now here notice I'm doing the actual dimension. I'm not pricing anything. I'm doing the actual dimensions because I want to figure out how many it's going to actually take. So 5.5 is the width of a deck plank. 2 by 6, so it's going to be a 5. Yeah, it's 5.5 inches. So 5/4, so 5 divided by 4 times 5.5 times 12 gives me 82.5 board feet, or no, it's cubic inches, sorry. So now I have to divide by 144 to get 0.5729. So divided by 144, 0.5729, and this is my board feet per linear foot. Now you notice I didn't clear my calculator because I'm going to keep that number in it. If I have this many board feet and I want to know how many linear feet it's going to be, I'm going to divide that by the 0.5729. But notice it wasn't 0.5729, it was 0.5729166666. So I'm going to do 560 divided by, I'm going to tell my calculator to use the previous answer. So second A and S. 977.45. That is linear feet. So depending on what length I decide to purchase, probably 16 footers if it's going to be a 32-foot deck. We're not going to all splice them in the middle, just so you know, for those of you that aren't familiar with it. We weren't worried about pricing that. We're just pricing the deck length. Well, the whole joists and posts and beams and stuff like that is a different thing. Well, that's just a different calculation. I'm just showing you an application of board feet. Joists you can always count by hand pretty simply. I mean, this is a 32-foot deck. If I'm estimating that 32-foot deck, you have 16-inch spacings. That's a 16 or 12 over 16, I should say, is the number of joists you're going to need. So that's 24 plus 1, so you get one on both ends. You need 25 joists if the joists are going that way. No. I'm just showing you the joists are something you can count by hand. You don't need board footage to calculate joists. That's all different. I'm just showing you board footage calculations, all I'm doing. I'm not talking about estimating here. So for you guys, let's say that you have a small room here with a little hallway. This is 16 feet, 22 feet. There you got it. 4 feet and 8 feet here. And what you're going to use, now this is actually going to be tongue and groove, but whatever comes out of here for the groove would be what would go there for the tongues. You don't have to worry about it. We're going to go 3/4 inch by 3-inch planks. Find out how many linear feet of flooring you're going to need. No, 3 inches is the coverage of the board. So what do we get for total floor area here? We got 16 by 22, which is 352, and 8 by 4, which is 32. So that does come out to 384 square feet. Times 3/4 of an inch thick. Gives us 288 board feet. How many of you got the 288? A lot of people missed it. You have to multiply by the 3/4 inches thick. Did anybody get the 288? Nobody got? A couple of you? Okay. So that's something you got to remember. You got to multiply by the thickness to get the board feet. So the 384 was the square footage of the floor, but the flooring is 3/4 of an inch thick. So now our flooring is 3/4 by 3 by 12. So 0.75 times 3 times 12 is going to give us 27 cubic inches per foot divided by 144. Giving us 0.1875. And this is board feet per linear feet. So what we're going to do is we're going to take our board foot divided by the 0.1875 again. Give us 1,536 linear feet. Now, I know that's not considering waste. You'd have a percentage you would add for waste because what you cut on one end doesn't always get fully used on the other. So 1,536 linear feet. Okay, in the big book, we're going to be dealing with page 272, exercise 9-8, and page 273, exercise 9-10. And then I'm going to hand out a packet. And in this packet, I want you to start page 211 through 212. in the packet. You guys don't get a quarter grade in here. It just matters by semester for this class because it's full 16 weeks. See ya.
Oh, ow, you're like Chris.
I'm pretty sure Chris is on that stick.
Except you put your head up. You actually don't read it. What?